This video is brought to you by MathGalaxy.com. This is our fractions program which covers these topics, and in this video we'll be looking at multiplying mixed numbers. Multiplication is just a shortcut for repeated addition. For example, 5 times 3 is just 3 repeated 5 times, or 5 rows of 3 each. But what if one of the numbers is a fraction? Here you have 2 rows of 3½ each. So you can't say you have 8 of anything meaningful. You could add 3½ plus 3½, but if the multiplier is large, like 50 times 3½, you wouldn't add 3½ 50 times. Well, the strategy with fraction multiplication is to make everything the same size. So if these were in halves, we convert these into halves. Each of these 3 becomes a half. And to do that, that's the same as making the fraction improper. You have 3 wholes, each becomes 2, that gives you 6, and plus 1 is 7. So now you have 2 rows of 7 each, and the pieces are the same size. So you have 14 pieces, but those pieces are now halves. If you put the 2 over 1, you can do what we did with simple fraction multiplication. 2 times 7 is 14, 1 times 2 is 2, and that reduces to 7. But what if the other number is a fraction? We have the same problem again, different size pieces, halves here and eighths here in this last quarter row. So again, the solution is to make the pieces the same size. If these are in eighths, we make these into eighths. So we have a quarter row here, so we make these into quarter rows. Again, that's the same as making the fraction improper. 2 rows, each becomes fourths of a row, plus we have a 9th fourth of a row here. So we have 9 rows, 4, 8, 9, of 7 each, 2, 4, 6, 7. And that's 63 pieces, and they're all the same size eighths, because the holes were cut into halves, then fourths. So 2 times 4 is 8, and 8 goes into 63 7 times, with 7 remainder. So that's the standard process for multiplying mixed numbers. Make them improper, then multiply across, and simplify. And another way of simplifying, like here you have 3 1/3, which becomes 10 thirds, 4 1/2 becomes 9 halves. So it gives us 96, dividing top and bottom by 3 gives us 30 halves, dividing top and bottom by 2 gives us 15. Well, if we can simplify there, we can simplify it at this step, because the numerator is 10 times 9, the denominator is 3 times 2. So as long as we divide top and bottom by the same number in pairs. So dividing top and bottom by 3, we get 3 into 3 once, 3 into 9 3 times. Then dividing top and bottom by 2 again, 2 goes into 2 once, into 10 5 times. Well, finally, the simplest way of reducing it is to do it up front. So as long as you can do them in pairs. So dividing top and bottom by 3 cancels those out, and dividing top and bottom by 2 cancels those out, and then 5 times 3 is 15. And that's also one way to tell whether a fraction can be reduced. For example, 2 2/3, 2 times 3 is 6, times 2 is 8, gives us 8 thirds, times 1 2/5. 5 times 1 is 5, 2 is 7/5. If the 8 won't cancel with the 3 or with the 5, and the 7 won't cancel with the 3 and the 5, you know you won't be able to reduce the final fraction. You still may have to turn it into a mixed number, though. Let's try an example. So for the first fraction, to make it improper, denominator is 2. 2 times 2 is 4, and 1 is 5. For second fraction, the denominator is 2. 2 times 9 is 18, and 1 is 19. Okay, so multiplying across, and okay, so now we have to simplify. 4 goes into it 23 times with 3 left over, and those pieces are fourths. Okay, so multiplying 2.5 times 9.5 is like having 9.5 in a row, and that row repeated 2.5 times. So our pieces are halves, then halves again, or fourths. And we have 5 rows of 19 each. So in this example, we need to make the numbers improper first. So the denominator is 3. 3 times 3 is 9. 1 is 10. And for the second number, 2 and a numerator of 3. Okay, so it looks like we can do some canceling. 2 goes into 10 5 times. 2 goes into 2 1 time. Okay, and we can cancel the 3's. 3 goes into 3 1 time, and into the 3 in the numerator 1 time. Okay, so now multiplying across, the denominator is 1, and the numerator is 5, so the answer is 5. Also, reducing up front saves you from really complicated reducing at the end. So if you had to multiply these across, you'd have a horrendous number. But here, if you saw that, you could cancel out that 17 with that 17, that 19 with that 19, and then dividing top and bottom by 15. You save a lot of work. Conversely, if you get a result like this after multiplying across and you're wondering if you can reduce it, you can save a lot of work by checking here. 15 doesn't cancel with 17 or 19, and 13 doesn't cancel with 17 or 19. So you know you can't reduce this any further. If you want more practice, you can go to MathGalaxy.com. The program has 2 modes. One talks you through problems step by step. The other asks only for a final answer. When you exit the final answer mode, you get a score, which you can also print out. And you can also earn robots by answering the problems that you can use in a maze game called The Labyrinth. There's also a riddles game that's like Wheel of Fortune, where the answer to math problems gives you clues as to the answer to a riddle. And Word Jumbles is similar, except it's based upon word jumbles. And there's also a game called Bridge the Swamp. This has been a review of multiplying mixed numbers. If you want more practice, you can go to MathGalaxy.com. Thank you for listening.